Our paper is about convergence analysis of two-layer neural network. The structure looks like this. We have an input X, and we pass it into a fully connected layer and get W transpose X, and then we pass it to ReLU and take the output of ReLU as the output of the whole network. Although this is a simple network, it turns out that it contains many bad local minima and saddle points. Therefore, it is hard to analyze the SGD dynamics for this network. What we did is we add a residual link into this network, which means the input of ReLU becomes the identity matrix plus W matrix transpose X. Essentially, what we did is shifting the W matrix by identity. By doing so, we showed that the optimization becomes significantly easier. Here is an illustration. If we do not have identity matrix, since we are using random initialization, the whole optimization process is around the origin, which seems hard because there are saddle points and local minima. However, if we have identity matrix, the whole optimization process will be around the identity matrix, which is the origin region, and we prove that this region is much easier to optimize for SGD. More specifically, we showed that SGD converges to the global minimum in two phases. In phase 1, the gradient might be pointing to the wrong direction. In the figure, the gradient is a red line, and we can see W1, which is the initial point, has gradient pointing to the opposite direction with respect to W star. Therefore, if we run SGD, we will be leaving away from W star. However, after running SGD for a few more steps, we will be entering a nice one-point convex region, which is phase 2. In this figure, phase 2 starts with W6. In phase 2, the gradient will be pointing to the approximately correct direction in the sense that it has positive inner product with the correct direction pointing to W star. Therefore, if we take small step size, we'll be getting closer and closer to W star after every iteration and finally converges. But how do we precisely characterize this process? We found that there exists a potential function g which controls the whole dynamics. If g is large, we showed that the inner product between the gradient direction and the correct direction to W star might be negative, which means we are in phase 1. But if g is small, we showed that the inner product will be positive, which means we will be converging to the global minimum. Moreover, we proved that by running SGD, the potential function g will be decreasing, which means we will be entering phase 2 from phase 1 and finally converges. This is also verified empirically, as we showed in this figure.